Hello and welcome to my second video on Let's Learn C for Beginners. In this video we will be covering loops, structs, typedefs and arrays, and then once we've learned all about those we can then proceed on to the game at the end, which puts all of these into practice. And there'll be a few other things in there as well, which I will explain. So let's jump into what is a loop and why you should use them. So what I'll also do is I'll open up my browser now and go to the online C compiler here. So in this video you can also follow along just using the online C compiler. However, in the next video, I will be looking to code on possibly the Game Boy. If you have another suggestion, possibly one of the other GBDK machines. So I'm also happy for the Game Boy Color, Game Gear or the Master System. Or if you want the NES, we can use VBCC for that. And the reason for that is we'll be doing something a bit more graphical, and we'll also go into more detail on memory and actually coding on consoles themselves, what differences there will be. So let's get back to this. So what is a loop and why should you use them? So whenever you need to do the same calculation or call a function over and over again, the best way to do this is inside a loop structure. As an example here, we will create a char A and we will give it the value A. So this is something you can do with chars as well, as they represent characters or numbers, basically the same to the computer here. So as an example, we can print that out as a number and it will give you the ASCII code, or using the %C here to print a character, you can get it to print out the ASCII text representation there. So as an example here, say we wanted to print out all of the alphabet from A to Z, then rather than print that out and then add 1 to A, the easiest way is to use a loop. So when you create a for loop, first you need to create a counter variable. So in this case we will just use this temporary variable n, and we'll start at 0, and then we want this loop to go for 25 times. The reason why we are saying 24 is because we obviously start at 0, and then we want the loop to increase by 1 each time round. Now what will happen here is all of this code in between the curly bracket at the top and the bottom there, everything inside here will be run over and over again while the value of n is smaller than 24 in this case. So the start, when it goes first time round, n will equal 0, then it will come back to the top here, n will then be added 1. So if I print that out, In fact, what we need to do is get rid of that hello world thing there. Let's run that again. There we go. You'll see that it's printed out from A to... Let's try that again. There we go. So that has printed out 25 times there. So you could also, if you want to see the value of n, we can do this here. So you'll see the first time round it's 0, then it's 1, 2, and then at the last time n equals 25. So the first part here is the definition of our counter. The second part here after the semicolon is the terms of the loop. So for example, we could do this instead. We'll start A at Z there, Z. We'll start n at 25, and then we'll say while n is greater than 0, minus minus n, and then we will also subtract 1 from A as well. Now if you run this, it starts at the end. And then finishes on 1. So if we do greater than or equal to, then we get the expected result there. So it doesn't need to be just 1 here. You could do, if we wanted to skip over every other letter, we could say n minus equals 2. So you'll see it's skipping over, n is skipping over every sort of 2 iterations there. And then we could do the same for A there. We could do A minus equals 2. Or we could put A as 33, and then we will run this 10 times. In fact, we will add 40 there, and then we'll do n plus equals 5, and then we'll print our character out, followed by the value of n. Oh, missed out a comma there. And now that's just skipped over a number of ASCII characters there from the character set there. So you see n is 0, 5, 10, 15, 20, 25, 30, and finishes at 35 because it's always while n is smaller than this evaluation here. So older versions of C. So C89 and C90, they didn't allow a local variable here to be created at the start of the loop here. So as a note, this variable n, it only exists inside these brackets here. If you try and print the value of n outside, it will generate an error. as n doesn't actually exist outside of this loop here. So you'll see here undeclared. So one thing to note is that that might not actually be picked up in all compilers. So if you try and do that outside the for loop, it might just run but give you like a really weird value. So now what will happen is we've defined n outside of the loop here. And then if we get the value at the end, so you'll see at the start the value of n is 10. Then inside the loop here it's then set to 0 at the start there, and then the +5 is done on the loop until n is greater than or equal to 14. Then it breaks out the loop and then it gives us the return value there. So that's the for loop there. So you could even if we created a function here, so what we've done here is inside this function, inside this for loop, we've called the function print my message and passed in the value. So another thing to note as well, if we change n to v, you'll see that this is valid as well, because at the time this is running, the value of v is active and alive, so you can pass that value to functions outside of the for loop, and that is still valid. But then as soon as this loop is finished, the value of v will no longer exist again. So that's an example of using for loops. So the other loops, there are do while loops and there are while loops. They all offer something slightly different. So a do while loop looks like this here, but then you must specify the evaluation part at the end here in the while part. So you give a reason why this loop will end. So say while a is smaller than, let's say 80, and then you finish with a semicolon on there. So this passed a to the function here and upgraded the char data type to an integer data type here. So unlike the for loop, you have your calculation part at the end here, and it is up to you to change the value inside the brackets here. So you change the counter. The do loop doesn't do it for you. So you can also have while a is not equal to 80. So if we set that to 50 there, I'll do a plus equals 5. So you could even do, let's set that to, in fact that will be over, it doesn't matter. So you can have multiply and subtraction as well. In fact, I don't know whether that will ever actually reach 80. Let's do that instead. So there we go. At the start, a is 5, and it multiplies by 2. It comes 10, then 20, then 40, and then it ends. So that might actually work then. Okay, it never actually reaches 160 for some reason here, so let's stop that. Why is that not working? Oh, well, yeah, that's why. As it's a char, it loops round at 127. That's why that wasn't working. So now this should work. There we go. So I could also have done this as well. So choose your data type wisely. So this will work as well while a is a short. So you can have that there means not equal to. There are a number of ways you can sort of express that. You could but yeah, it doesn't matter there. So that's a do while loop there. So what you can also do as well inside these loops is you can break out of them using a command called break. If you wanted to exit this loop early, for example, you could say while a is smaller than 50, no, while if a is greater or equal to 50, break. And then outside of the loop here we can say if a is not equal to 160, go in here. Oh, it's added another bracket in for us. There we go. So A exited the loop early here, so you'll see that it broke out here. Whereas if we comment this out, so what this does here is this comments out this bit of code here whenever you use two of the slash characters here. It makes the code invisible to the rest of the program. So you'll see here this run through properly here. So what we'll do here is if A is not equal to, is less than 160, then we'll get the value of it printed out. There we go. So this part of the if-else loop here, the if-else block of code here, is run because A equals 160 after the do-while loop here. So the other loop is the while loop. And that just looks like this. So this here is kind of like the for loop to some degree, in that the evaluation takes part at the top here. So for example, if we do while A is not equal to 5 and then run this, you'll see that this code in here doesn't actually run. Whereas if we say if A is less than 50, then the code inside here is run. So that's the loops there. So now we will move on. So yeah, there's nothing else I really want to go over here. I've pretty much covered everything from this slide here. So now we will go on to structs. So what is a struct? So a struct, or a structure, is a flexible data type in C that allows us to basically group a load of data which refers to one sort of object together in one part. So if I come back in here again and show you an example here. So say we wanted to represent a circle, for instance. So we create a struct called circle, and then we know that a circle should have a radius and it should have a center on the x coordinate and a center on the y coordinate. Now this here is now its own data type, so we can treat it just like any of the other data types here, Whereas if we were going to define a circle outside of a struct, we would have to name it like this. This is obviously fine for one circle, but if we needed more than one circle, it would be a pain to actually do. So the easiest way to group properties together for one sort of object or entity is to use a struct. So there are a couple ways we can define these after we've created the struct itself. So one thing you can do with a struct is you can have data types. You can name the variables after this. So you could have A and B here, which I don't like this terminology here. Now these are both structs. Now we've defined these as global structs, or rather global in this module here, and then we can do so you see here, to use the various properties of our created data types here, we just use the dot or the period after the variable's name, and then the internal variable inside the struct itself. So a better and cleaner way to name it would be to have our struct circle and then say A and B there. I think that looks cleaner, and you can actually see what's going on now. And then one thing to note as well is we can do this. And then what will happen here is the compiler will copy the values of the variables in A over into B. So as long as the data types in here are simple, they can be copied over correctly. However, if we have that one there, so if you have a string in here and then we say so we'll also have to include Okay, I didn't think it would have done that. I was expecting it not to copy that there, but obviously it did. Okay. So what we'll do here is we'll redefine A's message to goodbye there, and then we'll add the string there for A. So these are A's details there, and these are B's details here. So you see here we can simply copy structs here, and then if you wanted to pass this struct to a function or create a struct from a function, then you have to have the struct keyword and then the data type there, and then what you would have in here then is you would create a temporary struct, and then you would do, in fact we have to add each time you use the struct type, you need to put the struct keyword before the type name here. So our struct circle has to always be defined with struct before it here. So what you can call this sort of function here is it's like a builder function. As in, we call this function to create inside of it a new struct using the parameters we pass in, rather than having to manually do this every time we want to create one. And then at the end here, so what we could do is we can say B equals circle new, and then we'll say 250, 500, and then radius, let's say 55, and make sure that's longer there. And then if we run that, of course it's center X. There we go. We've created a new circle here using our circle new function here. Now if we wanted to pass this structure to a function, say we wanted to add two circles together, then we could do this, and then this would pass the structure into this function here. So I'm not sure if this is a good time to mention passing by value and passing by reference or not, but anyway, I will sort of mention this here. So if we passed A and B into this function, what would happen is they would be copied. You wouldn't be passing A or B to this function. So the values which would be changed for them inside here would be just like if we created a new variable in the for loop. The evaluations would occur with these copied circles here. And they would only exist within the curly braces here because these are passed by value rather than passed by reference. So what that means is when we pass these numbers here and this string here, these are being passed by value. These variables are created only in the function parameters, and then they are destroyed at the end of the function block here. They don't actually exist anywhere else. The same with these parameters here. They are passed by value, not by reference. So if we wanted to actually change these structures inside this function here, we would have to pass them by reference. And then what would happen is what we would actually be passing would be the memory address where the data for those structures lie, or even the memory address for a variable itself. So I'll give you a quick example here. So I'll quickly clear these away a moment here. So we'll have our integer here and we'll say my number equals 5. Now we'll call the pass by reference function first. And then if we pass in my number, so for us to pass this by reference, we have to use the ampersand or an symbol here, and then if we print the value of that afterwards, and then we'll print the value of it beforehand as well. Okay, come on. Okay, why has it done that? Yeah, that doesn't seem to be working as expected there. I'll double check that a minute. I'm sure that's not right there. Let's just copy that across a moment. Yeah, as I thought, I don't know why that's not working properly. So what should be happening is the value in here, when we pass this by reference to this function here, the memory address should be, the value at that address should be incremented by 1 here. Okay, I didn't know that the browser was glitchy like that. So I'll show you it properly in a moment. Let's copy both of these out of here. Looks like I will have to be doing this outside of the browser after all then. So we'll oh no, why is that then? Is it because of that? No, it's not. What am I doing wrong there then? My number equals 5. Pass by reference, my number. What am I doing wrong there then? Okay, why is that working then? Bizarre, I don't get why that's not doing that. So it's working in that form, not that form. Very strange. So what's happening is the value in there, if we change it inside a function where the variable is passed by reference here, as in this is being passed as a pointer, I'll explain what those are in a later video, then we can change the value of a variable inside the function block here. However, if we pass by reference here, or sorry, pass by value, then there won't be any change at all, regardless of how we change it in here. This is what I was trying to get over here. So maybe that will actually work if I okay, it's working now. I don't get that at all. Okay, so it does work. So if we pass these structs here by reference, we can do I don't know how this is going to work with the string though. Let's get rid of that. Okay, circle A. And then we will pass in A there and B there by reference, and then so what's going to happen here is circle 2 will be added to circle 1 there. Okay, it needs to be that. Okay, it's not going to let us add them together like that. So, okay, what we'll have to do then is So that slowly worked there. So as a note here, when you pass something by reference or by pointer, instead of the dot, you have to use this symbol here, which allows you to access the properties. So you have to kind of, when you're passing them by pointer, you have to individually add things, whereas when you are working with them as value, so when you define them normally, you could just do will this work here? No, it won't. Okay, so you have to operate on the properties individually. Anyway, this is an example of why you would use structs here. So this is a circle here, but you could also do something more interesting, like say actor here, and then you could have, say, health, strength, and then you could have, say, another struct which would be like position, and then you could include that struct in here then. And then you can basically create structs inside other structs here, so you could sort of continue on putting these things inside one another to get the desired complexity that you want. The idea is that these structures allow you to group common properties so that you can kind of visualize real-world objects and data. So this is my that's my long-winded struct code there. So we will now move on. So basically this is just going over all of what I did there. So I'll now introduce the typedef keyword. So the typedef keyword here, what this allows us to do is to speed up our programs. So if we, for example, use the typedef keyword here and then struct, then at the end here we give the name of our typedef. So all the typedef command basically does is it says this is our user defined data type, which is the same as this other data type. So I will give you an example now of the usefulness of the typedef keyword. So if we imagine, so using unsigned characters here, say we byte A, say, or something like that. So instead of using the having to type out unsigned char all the time, we can say typedef unsigned char byte, and then what we can do is we can use byte as a new data type. So we can say byte A, B and C. And then so with the typedef we can create 3 bytes here, A, B and C, and then we can treat them as if they are their own data type. However, if we print out the size of A, we'll see it takes up 1 byte there. And what we can also do as well there we go. So we can treat our new data type just like an unsigned char, and everything the unsigned char can do, our new data type can do, except we obviously don't need to type out so many words to use it each time. So as we will be using GBDK next, or VBCC, one of their data types they use is a U8 data type, which basically is an unsigned char, but it allows us to easily identify that U for unsigned and 8 for 8-bit. So another useful one as well is unsigned short. We could do U16 here. Now anytime we need to use an unsigned short, we can just do U16 my number here, and then if we print the size of my number there, that should give us 2 bytes there. There we go, this is acting slow now for some reason. So that might not look that great there. But what you can do is so just like we had previously, the circle type there. Now instead of having to do struct all the time, we can just do and now if we want to create a new one, we can just say circle so you'll see it can make things a lot faster for you using Typedefs. And then we can say A equals circle new, and then we can say 10, 10, 10. And then and we can have another circle, we can have another function. And then we'll pass this one by value, as we don't need to change anything here. And we can now print out our circle. Oh, I've spelt that wrong. There we go, sorry about that. The autocomplete doesn't quite work in the browser as it does normally. So there we go, we've created a typedef struct called circle. So you see here we don't have to include struct every time we use our new data type, as long as we use the typedef format here. We can treat this just like it was any other normal data type, and then we can also use custom data types, which underneath them are the long C name of the same. So the example code here basically just shows exactly the same here. So my example here, I basically created like a rectangle type here. So we will now go on to what are arrays and why you need them. So if we have a whole group of objects or integers or chars, then we need to create what's called an array. So you can see here we've created an array of chars here. So you'll see that that's the same as a string. So we've already been working with arrays anyway. So what this actually does here is it says I want to create 30 chars and then put them in this variable called my message. So we could equally, we can have my map, and then we can have what's called a multi-dimensional array. So this here is a single dimensional array. So these numbers, if you like, you can think of them as like a list. So when we create this array like this, everything inside here should be initialized to 0. Equally, we can have what's called a multi-dimensional array, so we can say that there. Now what this actually creates is 10 blocks of 10 here. You could even go for a 3-dimensional array here. And then to access an array, you would then say, so if we were using our message there, you then put the index of the data type you wish to assign a value to. So then what you can do with your char array is you can print it out. So what we've done here is basically the same as sort of creating a const array here. So the difference here is this is actually passing a constant array of chars. The thing is, the computer will work out, or rather the compiler will work out the length of the string depending on how many characters you pass in. So if we said new string and then we put my characters here, what would happen is the compiler will work out how many letters are in this array here, and then it will pass the address here where the computer stores this array locally in its memory. Or if you wish to create these strings yourself, then you can do exactly the same, but this is what's actually happening behind the scenes. There is an array of chars created somewhere, and then each letter is assigned to an index of that string there. So for example, what you could do now is you could use the string copy from strings.h, and then you can put in my message here. So one thing to note is these functions here, they expect a reference to a variable which is a pointer, as the reference is pointing to the memory address where that data for that variable is actually stored. So you can treat an array just as if it was a pointer when you are working with them, like this. So now what we can do is we can say new string my characters, and then print out my message here. And you'll see it prints out my characters. And then we can say afterwards get the length of the string which is inside my message. Remember, my message is our variable declared here. So anything declared outside of functions inside a module are global variables inside that module. What that means is these variables can be seen by every function inside this module. Whereas if you declare a variable inside here, then this variable is said to be local to the function block where it is created. Hopefully that makes some sense to you. If you've been looking at other tutorials, it will. In time, all of it will kind of fit into place. So what we can do here now is we can say print out the length of the string in my message. And you'll see it's printed out 13 here, which is the length of these. One thing to note as well is that there, when these strings are being created, there's actually a hidden character which is put at the end of these strings, and that hidden character is the number 0. And I can show you that. Well, if we passed in a string which was exactly 30 characters long, then it would glitch out, or it should do. So if I do this here, we know that 13 characters is what it's saying. So what will happen now? Okay, that's actually a memory leak. What's happening now? Anyway, this is insecure. This function here, it's a better one to use is, where are we here? No, it's this string one here. String is this one here, and the reason why is because it asks for the size of the string. And then what it will do is it will copy characters from this array of characters to the destination array of characters, and it will only copy up to a maximum size that you specify here. So if the sentence length is longer than the amount of characters you have in your destination, then it won't cause a memory leak or crash your program, which is what could have happened just now. Because this array here, like I said, it has 13 characters, but there is a hidden character at the end. There has to be, these strings are what's called null terminated strings, which means the printf function here, it reads every character and then will only stop reading when it finds the value 0 in that character array. So another thing you can use is defines here. So this keyword here is useful for creating the size of various things. So this is like a constant. This is like a constant here. It's not a variable as such. When the program is built, everywhere the compiler finds this variable here. So say my string length when you use defines, when the program is built, the compiler, when it runs through your text, wherever it finds this string of text which is used in a define, it will substitute it for the number you specify. So you can say that basically this number is like a constant, as in it can't be changed. So now we can use the strncopy function, and then we can say my string length there. And now this should glitch out. So this is expected here because there is no space. So now what we need to do after the new string here is we need to say and then that will print out. So that's something to be aware of here. You always need to include, when you are sort of creating strings yourself, which on the desktop you probably will not do, but when we work with actual old consoles, we won't be using the printfs because they take up a lot of memory. So lots of these functions here we will sort of create ourselves when we code on the console. So anyway, this was just something to throw out there. So the reason why, let's get rid of some of this here. So the arrays basically allow you to create like large groups and lists of key data types here. So example, if you had a game, say we had our ghost. So we said it has a X position in the world, a Y position, and say it has a damage value. Then say in our game, so we've got this is our game here, so our map, or say level 1 here, so we've got 10 by 10 tiles or rooms, caves even, whatever you want to say that they are. So now we want to have a number of ghosts which could be in any one of those rooms there. So we say, so we'll have a ghost, and we'll say my ghost list, and then we might have like 20 ghosts, for example, here. So how would we create these ghosts? Well, the easiest way is to use a for loop, isn't it? So we would say t equals 0 to 20, t plus plus, and then in here we could have my ghost list, and then if we put T to reference the index of our ghost, then we can have x equals, and we can set x to T. And then what this will do here is this will create our 20 ghosts for us. However, we know that there's 20, so why not just use a define? Then if we need to change the amount of ghosts, say we need to increase the difficulty or reduce the difficulty, we can use our define here. Same for the for loop as well, so we want to try and automate as much as we can. So we've created our 20 ghosts now. So now let's print out the details for 10 of our ghosts. So we can say ghost max divided by 2. However, a better way to specify this here would be and the reason why it's better than doing this calculation in here is because this calculation is run every time this for loop executes, which obviously doesn't matter on a desktop, but on a slower computer it actually will matter. So we could print out each individual thing, or we can just do a function to do it all for us. And then let's just pass our ghost by reference. So we can then do this here. And then we can say ghost details, and then we can use a new line thing in here, and we can print out the position. So we can say location, and then damage, okay, let's pass that by referencing. There we go. So we have details here for 10 of our ghosts here. So we have their locations and the amount of damage they do. So this one, the first one will do no damage at all, and then they go up. Incrementally here. So this demonstrates here creating a single array of ghosts. So now we need to talk about multi-dimensional arrays here. So the order that these are in is important here. So the way it works is it is always from the right hand side first. So the first 10 integers in our level would be level 1, so level 100 would be the first location on our level. Location 09, this would be equivalent to the, if you think of this as like a grid, then this would be y, x here. So this would be the equivalent of this. So it goes, so we think about this. So if we were going to define the data in an array, then this is the first 10 here, then that's the second 10, the third 10, the fourth 10, the fifth, and so on. So the start here is 0, 0. The start here is 1, 0. The start here is 2, 0. And so on. So you can think of, so if you think of this as like a grid, then that's y there, and that's the x-axis there. Now our 3D map here would be similar to this here, except what would be happening is the 10 part here, so it would be doing this first, then it would be doing 10, so it would create a whole load of these first. So let me see, we've got 1, 2, 3, 4, we've got 5 here, so I'll copy another of those here. So there we go, that's our 10 by 10 grid there. Now in a 3D map here, to set this up, this whole first area there, that would be my 3D map. That would be like 0, 0, 0 would be the start here. Then 0, 1, 0 would be this line. And then if we were to sort of create this here, so if this was Z there, that was Y there, and that was X there, then this, all of this here would be 0 on the Z axis here. Anything in this block of 10 would be 1 on the Z axis. So it's kind of like multiplication there. So it's like this is 10 times 10, and then this here is basically y times x times z. So this would be 10 times the amount of y times x. So to contain the same data, this would be the same as 10 times 10 times 10, which would create a single array with the same space as that there. So if I do that one there, and then I will show you what I'm saying is true. So what we'll also have here is so what this is here is this is what's known as a dynamic array, and this is what's known as a static array. And the reason why is because at the start here we have passed in the sizes of these array dimensions, whereas this one here says this is also a static array. However, I'm not going to give you the size. I will give you instead the creation of that, which won't change. So what this has done here is this has also created a 10 by 10 level, and it is already, you can already complete the data here and pass into here. Hopefully that makes sense to you here. So you can either define an array with parameters here at the start, and then you can alter its contents throughout the duration of your program. However, you can also create a static array and dynamically allocate the data into it at the start, which is what this is doing here. So we could have, for example, so I'm not going to do any more of that because the online compiler here is blocking me from changing this here. So you can partially you can complete the data yourself here. So this could be a level here, and then we could have say level tile wall, and then that could be 4, and then we could say 5 there. That could be a ghost, for example. So we know that the size of this here is 10 by 10, and we know that we want our level to be 10 by 10. So we can use a define again for this. So we can say level width 10, level height 10, and then we can do level height and level width there. And then we can go through this here. So let's say we want to find the ghost in this data here for level 1. So we can first create a tile which will hold the one character from our array here, and then we can use a for loop. So we can say for int x equals 0, well, x is smaller than level width. In fact, no, we want to do it on the y-axis first. So y equals 0, well, y is smaller than level height, y plus plus. And then do the same on the x-axis. And then in here we will say tile ID equals my data, and then we can say x plus y times level width, and then we can say if tile ID equals level tile ghost, and then we can say found the ghost, it's at and then we can use the local variables that we've created here. So what this will do here is this will crawl over each character in our level data here, and there we go, it's found the ghost at 4 by 4, and there it is, 4 by 4. So one thing to note is obviously this goes from 0, so it's actually that's 0, 1, 2, 3, 4 on the x-axis there going across, and then 0, 1, 2, 3, 4 on the y-axis going down from the top here. So the top left of our data here is basically 0, 0 on our map. So what we could do now is say we wanted to fill in our level with the data here from this array, then what we can do here is we can say my, what did I say it was, level 1. You can say level 1 y x equals tile ID, and then we can say press enter to draw map, and then we can do exactly the same again. Y, in fact, let's declare two variables, width and height, set them to 0, and then we will use do and while. So say while height is smaller than level height, and then we will say width equals 0, do while w is smaller than level width, and then outside of this we will print a new line, and then we will get the tile ID from level 1 height width, and then in fact we'll just say find the ghost again. So what will happen here is at the start here, width and height is 0, and then we are basically doing exactly the same as you would do in the for loop here, except using do and while. So you'll see that W is reset to 0 at the start bit here, and then we are using H and W here from our level instead of the raw data there. Oh, there we go, yep. Try that again. And there it goes again. So we found the ghost here, and then we plotted the level data into our level, and then we were able to using our level, we were then able to take a tile out and then find the ghost again. So hopefully that all makes sense to you, how we can use arrays. So now I am done in the browser here. So I've gone over arrays here. So now what's left to do is for us to jump into the ghost code for the game Haunted Cave. So what I will do now is I will open up the text file, or rather the C file here, and I'll copy that into this project here. So first the game asks you for difficulty between 1 and 8. So the cave is, I think it's 8 by 8 tiles, and depending on the difficulty depends how many ghosts are actually in the cave. So we'll say 2 to start with, and then it says you've entered the dreaded haunted cave. Legend says there are treasures inside. It is very dark in here. You can only just see your feet. You believe the cave is 8 by 8 in size. You can't climb out the way you came in as the rope snapped. Legend also says this cave has a terrible ghost haunting it. Can you find your way out and also get some treasures? And then we have some commands you can use to navigate the cave. Again, using the scanf function from the previous video. So we can either type in N or north or east or west or south, and then you start at a random location each time. In fact, what I'll do is instead of running it directly, I will go back into the browser again, as this will be the final browser game. And I think I can yeah, I can zoom in on this a bit better here. So there we go. So enter a difficulty between 1 and 8. So we'll go with 2. And then there we go, the start again. So our starting location is 07. So that's where we are in the cave. So I will go north. So 7 here is basically at the bottom of the cave where we come in. So we go north. So we're now at location 06. So we've gone up. So if I say go to the east, we then go 1 tile to the east, go back the way we came, and then if I try and go past 0 on the X tile position, then it says you walk into the cave wall. Ouch. So let's go to the east again. Let's see what happens if I just type in random characters. It says you can't do that, so it kind of limits you to the commands you can type in. I was going to go for a whole sort of mini adventure game, but it obviously would not work in the browser, so I decided to cancel that. And we'll go for more interesting programs next time in whatever console I decide. Let me know if you've got any sort of preferences you want me to do with regards to the NES, the Game Boy, or the Master System or Game Gear. Those are the options, because the GBDK compiler and VBCC are straightforward, and the emulators for them are nice and easy as well for you to use. So I'll quickly go through this now. So you gain score in the game as well. So we found a silver coin here. There are a number of coins to find. So I'm just going to go in a straight line here. So what we're trying to find is there's an exit somewhere in this cave. So we are literally at the northern wall of this cave now. So if we go to the west, okay, so we know that's not to the west. So if I keep going to the east, there we go. So I found the exit and I've made it out alive. I scored 300 points and I played 13 turns. So let's go into hardcore mode now. So if we run it again, so let's put our difficulty to 8. So we've entered our cave again at the bottom. So let's try dashing straight for the north wall again. Okay, so we've managed to go 1 step into it. We found a silver coin. Oh, and we've hit a ghost. So we only played 4 turns that time and we scored 50 points. So I will now quickly go over the code for this and then end the video there, as it's gone on for quite long enough, I think. So the defines for our game are here. One of the other things I'll quickly cover now is the enum data type, and more specifically what this is it's an anonymous enumeration type. So what the enumeration type allows us to do is it allows us to create constants and give values to these. So what happens here is this first type here is given the value 0, and then every subsequent type afterwards is automatically numbered for us. So the value here of tplayer is 1, gold is 2, silver is 3, and ghost is 4. So enumerations are an easy way for us to create values and arrays of a set type, which is what it's done here. It's grouped these together here. These all make sense as a group, and then to access these you would literally just say int my number equals eCaveGhost, and that would assign the value from this as an integer. Or if you wanted to, you could, if you use enumerations like this, what this does is it means you have to create a type called colors before you can use the values in here. So that could also be useful as well, although I prefer the anonymous enumeration type here. So what you would do then is you would have define it like this, and then the value of my color would only be able to be any of these here. However, I find the anonymous type to be more useful here. You see I use it again here for commands. So the you see here the typedefs in use again. Instead of unsigned int, we'll have u32. Instead of unsigned char, u8. So these represent tile types in our map. These are a load of constant strings here for the available commands. So all of these are in lowercase. And the reason for that is when you use scanf to read in keys from the keyboard, everything is case sensitive. So when you use the string command, string compare, which is down here somewhere, here we go. So this function here, this will compare two strings together. You pass in them here, and then if the value equals 0, then it means they match. So what this is doing here is we are getting an input using scanf, storing it in our command string, and then what we do is we go through each character in that string, and then we use this command here called toLower, and what that will do is it will convert the character into a lowercase character. So you can find that function in the C type header here, which I recommend you have a look at. This allows you to compare data types to different things to ensure they are something that you want them to be. So for example, you can use the toOpper function or toLower function here, and then what that will do is the toOpper takes in an int, and then the value of that int should be the ASCII representation of a character, and then it will then convert any of the lowercase letters that it finds to the uppercase characters that it finds. The lowercase will do that, obviously the opposite way round. You can use these ones here to check to see whether the value is an alphanumerical value. What that means is the number corresponds to a letter in the ASCII alphabet. So the result will be true or false there if it is or it isn't. So that's a useful one there for you. And then you can also check to see whether it's actually a digit. So that will check to make sure that what's passed in here is actually an ASCII number. So if you remember from the other week when I pulled up the ASCII character set, there were 0 to 9 are like digits in there. So it checks to see whether this character is in that range in the ASCII set. Useful for various compares here. In this case, I'm just using it to make sure that when we read input from the player that it's always lowercase, so we can compare them to the commands here. So these are the command strings, and these represent ID numbers for these commands. So for example, we have a data type which is a command, and it will have a string, and it will also have an integer which basically says what that command is. So it allows us to have a number of different commands which all correspond internally to the command north here. So for example, you could have forward, for example, and then you could have F. And then we also have to add that command here. So this is a list of our commands in the game here. So a command, it takes in a string which the player types in and wishes to do, but then internally there are only a limited number of commands, so each string is kind of mapped or paired with a command ID. So now I've just added those two extras here. I need to go through and renumber these. I probably shouldn't have done that, I don't know. Okay, what have I done there? There we go. So set difficulty is 5. So we should be able to go forward now as well. So you'll see we type in F to go forward, and it's classing that as going north. So you could add in more command IDs here, and then you would also if you add more commands in here, then they need to kind of pair up with a command ID, because when you go to convert the logic from what the player has asked into a command, the new command text will need to match an ID, and then the ID is what you kind of work on. And then we have some strings here for the entities that can be found on the map. These here, they basically correspond to the tile types here. We don't include the player or the empty type. So these types here actually get plotted onto the actual map. So you'll see here what I was going over previously with the level is actually being used here with the cave map. And then we just this just plots a tile on the cave map. And then the game itself, I could have put the player's properties in a struct really. And then the exit has its own X and Y here. Again, that could have been put in a struct. So this function here just initializes the game here. And then this bit here, what this is doing here is it is finding out how many commands there actually are. So it is reading this list of strings here until it finds the star character, and then it breaks out of it. And it basically counts how many commands there are at the start and stores them in the command count variable here. That's what this is doing here. And then you'll see here that if the do while loop, if the character were reading from the string commands, the first character is a star or an asterisk, then the this command here allows us to basically break out of the do while loop here. And then this just sets up the player to a random number at the bottom of the cave. Then this function here then plots the player's tile at the start here to player X and player Y. And this is so that we can use do while loops to randomly plot ghosts into the cave. And then at the bottom here there's also what we're doing here is oh yeah, we're just here we're asking the player to enter a difficulty number, and then while the number they type is not greater than the maximum amount of ghosts, we'll basically stay in here and print a message saying enter again basically. And then this here just plots random positions for the ghosts. the ghost x and ghost y are just temporary variables inside the game initialize function here. And then we also populate a load of coins, and then at the end here we clear the tile where the player starts. The only reason why we sort of plotted it at the start there was so that the random numbers for the ghosts and the coins wouldn't be overwriting the tile where the player was located. And then the other function of interest here is the get input function, which I was going over previously here. So this string here for the command is basically a local variable inside here, and the get input will return a number. The number will be the command ID from the list of commands here. So what should happen is when the player inputs some text, we'll go through this list here and we'll compare each string against the strings in here, and then depending on where we find the string, which string number in our list, we keep that ID number, and then whichever ID number is found, we pass that back. That's obviously that there, and then that just uses a string compare to find it, returns the command ID. If it returns -1, then it means what you've entered is not recognized as a command. So this is the entry into the program here, int main. So you'll see we have a Boolean value to say whether the player moved or not. And then we have a number to get the input ID from the player. So the core game itself, scroll out, make the text a bit smaller here, is inside the do while loop here. And then the game will continue while the player is alive. Once you've died or you've found the exit, the game will finish here and it will say what you scored, how many turns you took to do so. And then at the end we basically wait for a key press before finishing the program. Otherwise the program will exit if you are running it in a terminal window or a console window. So one other thing I will talk about first before I end this. I'm not going to go through everything. I've gone through all of the parts. It will be up to you to decipher some of this on your own. So the main thing I want to talk about here is the this thing here called a switch block. So I will create a new instance of this window here, and I will explain the switch block before I end the video. So a switch block allows you to easily compare a value against a load of other values. That kind of sounds not very descriptive there, so we will do an example here. So we will have an enumeration here, and then we'll say define a load of colors here. And we'll say int a equals brown. So maybe we want to find the exact color that A represents here in our switch block. So you could use various ifs and else ifs. But an easier way is to use the switch block. So for example, you could say if A equals E color red, then you would say whatever in there, and then you'd have to do else if A equals E color green, and then another else if and so on and so forth. And one thing to note as well is these will be assigned a value in here, so the value you compare against needs to kind of be in order here as well. So rather than do a load of ifs like that, you can say case, and then you have to put a colon and then break. So you put your code in here if this case occurs, and then you go on to the next one. And then one thing you can do in here is, say we want to treat brown and blue the same, and say brown, blue, and break. And then another useful thing you can do is, if the value of A doesn't fall into any of your categories here, then you can have the default keyword here. I can't remember if that takes a colon or a semicolon. And then you would say just run that a moment, see whether that's an error. Okay, I'm missing a colon somewhere. Ah, there we go. I need to put a colon after the enumeration there. There we go. So A equals color brown. So this one here has run. So we could say that equals blue. And that one will run. And then Don't worry about the spelling, I'm just trying to get this done quickly so that this video doesn't go on for like 3 hours again. There we go, so we've got red there. So we'll just give A a random number now, so 60. And there we go, now it's been caught by the default part here. So this is a quick example of using enumerations here in a switch block. While you would use a switch block, it allows you to compare a value against a state, if you like, of predefined values here, and then if it falls outside of that range, then you can use the default part to catch that error. So that's it for this video. Hopefully you will find it useful. I will have the programs in a C file again for you to copy into either your own development environment which you're using, or the browser here. And then in the next video you will need to go through my, well, I need to know first what console you'd like me to develop on. If I don't get any responses, then I will just go with GBDK. So let me know if you've got any questions in the comments below, and I will catch you in the next video. Thanks for watching.